Hey everyone, today we're gonna explore queues. Alright, so let's kick things off by talking about what a queue actually is. In computer science, a queue is a linear data structure that follows the first in, first out principle, FIFO. So what is first gets served first. Now there are two key operations that define a queue. InQueue, which is adding an element at the back of the queue, and DQ, which is removing an element from the front. And of course, the order in which elements are processed is crucial. First in, first out. We start with an empty queue and insert the element 1. It is added from the backside, and since the queue is empty, it is first in line. The same if we insert element 2, and it is added behind element 1. And so on with element 3. Now we dequeue our first element, removing one which was the first element added to the queue. And we have then the rest of the elements at front. The same if we dequeue element 2, and we'll have element 3 at front. Now let's talk about how queues are implemented in programming. In many languages you will have built-in or library-supported implementations of queues. Let me show you a basic example in Java. In Java, we are using the queue interface, and for this example, we are implementing it with a linked list. Next up, let's add some elements to our queue. We will use the add method for this, so we can add 3 elements here. Now let's take a look at what our queue looks like at this point. So we can see we have the 3 elements inside our queue. So as queues follow the first in, first out principle, so let's remove the front element using the poll method, and let's check the removed element. And after that, let's see the content of our updated queue. And if we are curious about the front element without removing it, we can use the peek method. Queues are not just an abstract concept, they are widely used in real-world scenarios. Think of them in terms of print spooling, where the computer manages to print documents in the order you have requested them. Or task scheduling in operating systems, where processes are managed using queues. The system schedules tasks based on priority or in a first-come, first-served manner. Or even in algorithms like breadth-first search in graphs, where nodes are visited in layers, maintaining a queue of the next nodes to explore. Finally, let's touch upon the time complexity of basic queue operations. Generally, InQueue and DQ operations have big of one-time complexity. Alright, that's a wrap for today's video on queues. I hope you found this helpful. Thanks for watching.